Hello. In this video, I'm going to be solving two exercises from section 2.1 of Jiří Lebl's notes on Diffy Qs. The link to the notes will be in the description. So our two exercises are right here. I'm going to be doing two exercises on linear independence. The first of which is 2.1.101, which asks, are sine of x and e to the x linearly independent? Justify. And then the second exercise is 2.1.102. And this one asks, are e to the x and e to the x plus 2 linearly independent? Justify. So how are we going to attack this? Well, in general, whenever you're asking if two functions are linearly independent, you want to determine, backwards. If you're trying to determine if two functions, say f and g, and I'll write this in green actually, because this is something we should recall. So let me change the color. Oh, I forgot how to do that. Okay. So first recall. F of x and g of x are linearly dependent. So the opposites of independence. If we can write f of x equals c times g of x for some constant c. And here what's being implied is that this should be true for every possible value of x that you can plug in to the domains of f and g. And so this leads to f of x and g of x are linearly independent. If they are not linearly dependent. And so what does this mean for determining linear independence? What we can do is we can set, and I'll put this in words, set sine of x equal to some constant e to the x. And there's going to be two possibilities. If we solve for c, and get a constant function, actually, maybe I shouldn't bullet this because I'm going to run out of space. So let me move this over. So if we solve for c and we get a constant function, then these guys are going to be linearly dependent. Then sine x and e to the x are linearly dependent. Right? Because then, well, c will be constants. It'll be some constants. And so we will have succeeded in writing sine of x as some constant multiple of e to the x. On the other hand, if c is not a constant function, then sine of x and e to the x are, as you might guess, linearly independent now. And so the procedure for determining linear independence is simply taking sine of x, one of our functions, setting it equal to some c times the other function e to the x, and then we're going to solve for c. So c is sine of x all over e to the x. Okay. Now we have to ask, is this constant? So is the right side constant? And intuitively, some of you might already say, oh, obviously. I mean, you're taking a function, sine, and you're dividing it by another function. And so that shouldn't give us something constant, right? But what's like an airtight way that we could see this, right? What's something that we could do to see for ourselves that c is not a constant? Well, we could try plugging in different values for x. So if we try x equals 0, well, sine of 0 is 0, so this whole thing's going to be 0. So we get c is equal to 0. On the other hand, if we try x equal to, say, pi over 2, then we get c is equal to sine of pi over 2 all over e to the pi over 2, which is 1 over e to the pi over 2. And here, because the top and bottom are both positive, so remember that e to the x is positive for any x, we see that this is positive. And so what this tells me is that since 0 does not equal 1 over e to the pi over 2, again, because we know that this number is positive, we have shown that c is not constant. I mean, if it were constant, then no matter which values we plug in, we would get the same answer. So in particular, the value that we get when we plug in x equals 0 should be the same as the value we get when we plug in x equals pi over 2. Evidently, that's not the case. So this means, conclusion, sine of x and e to the x are linearly independent. What about these next two functions, e to the x and e to the x plus 2? Well, same thing. So we're going to set one of our functions equal to some c times the other function. So I'm going to do it like this. And so solving for c, so we start here. We get that c is equal to e to the x all over e to the x plus 2. And we can simplify this by using properties of exponentials. So the bottom becomes e to the x, e to the 2, and this is 1 over e to the 2. Notice that this right side is a constant function. There's no x variables. This is just a fixed number, and so this is a constant. And so this tells me that in this case, these two functions actually are linear. They're not linearly independent. That is, they are dependent. So since 1 over e squared is some constant, c is a constant function, or even more simply, c is a constant, and therefore, in this case, our functions are linearly dependent. E to the x and e to the x plus 2 are not linearly independent. Oops. Not linearly independent. In other words, they are linearly dependent. And this will be the general procedure whenever you're trying to determine if two functions you're given are linearly independent or linearly dependent. So to summarize, we take our first function, we set it equal to c times the other function, we solve for c, and then we want to check whether the thing we get on the right side is a constant function or not. If it's not, as we saw in this example right here, then your functions are linearly independent. And if it is a constant, as in this case, then your functions are linearly dependent. Okay, that wraps up this video. If there are any questions, please feel free to leave a comment. Otherwise, I'll see you all in the next video.